So Bernardo, there's so many companies implementing LLMs these days, either as part of their existing offering or as completely new products. And it seems like the default choice is to go with a closed source model like GPT-4 or GPT 3.5. Why is that?
Yeah, but you're right. Yeah, normally you could go for closed source models in the beginning. I think the main reason is that these models are easy to use and at the same time they are very powerful. So these are actually the most powerful models out there, LLMs like GPT-4 or Claude by Anthropic as well. And when I say that they are easy to use is that they perform very well across many different tasks and domains, but also they are deployed for you. They are behind an API and you just need to call an endpoint, send there like your prompt, and then you'll get the output. And you could tweak some hyperparameters as well, but they are quite easy to get started with them. That's probably the main reason, and that's fine for the prototyping phase, I would say, when you are getting started or you are trying something new, unless you have perhaps very strict privacy requirements, but that's usually not the case for many companies. So yeah, like there's nothing wrong with going with closed source model in the beginning. I would say also all the tutorials, not all, but most of them are using LLMs, closed source LLMs. So it's actually like a natural tendency that if you are like looking at materials and then they use closed source LLMs, then okay, you'll continue with the same LLM. But as you move forward the prototyping phase, I think companies should basically ask themselves if they need to use closed source models or they could use open LLMs. Closed source models are typically quite large, quite big. They have many parameters. They are general purpose models. So if you have a very specific use case, you might benefit more from specialized smaller model that is faster and perhaps cheaper to run. So companies should ask those questions themselves. Also, IP is important as well. Like maybe if you continue using closed source LLMs, you're gonna create a huge lock-in with, in that sense. So yeah, I would say those are the main reasons. Actually, what do you think, Aro? Because when we started Fluoride, Carlos and you basically built Fluoride on top of GPT models, right? So why did you make that decision at that time?
Yeah, it's been a while. So we started back in 2020, and back then GPT-3 had just been launched and we got a very early access to it. Of course, GPT-2 was already available, but that was practically unusable. And looking back, even GPT-3 was quite an unusable one. So that was the only option out there. And we didn't really have the privilege to be able to choose from such a variety of models that we have these days, and even like across closed source and open source. That wasn't really a consideration back then.
Yeah, that makes sense. But now I think, as you said, at that time, there wasn't really a consideration, but now I think it should be a consideration because we have like a plethora of very powerful LLMs out there, different sizes, different kind of architectures. So,
right.
Yeah.
So the plan of today's episode is to introduce our audience to open source LLMs. And we've started to use the term open LLMs. So what is the definition actually?
Yeah, that's a really good question. So initially when companies like Meta, for example, started to release models like Llama 2, we were considering them like open source models because we were using the same definition of open source as the one adopted for software, like open source software. But that definition is not perfect for LLMs because an LLM really consists of the training data that was used for creating that model, the training code as well, and the architecture, so how that model was implemented and how it was trained, and then obviously the weights, so basically all the parameters that capture the knowledge in the data, right? So in order for a model to be fully open source, these three things should be made open source as well. And that's not the case in many of these LLMs. For example, Llama 2 and Llama 3, they are not fully open source because you only have access to the architecture and the weights. You don't know the data that was trained. You know a little bit about the training recipe, but they might not disclose all the details. So now we have this term open LLM, which means that, okay, the model weights are available for the community. Sometimes you could use them for commercial use, like in the Llama 3 or Llama 2 license. It's like a custom license by Meta. You could use the model for commercial purposes, but there are some restrictions. So you need to like really read through the license. In the case of Llama, I think that if your product has more than, I think that 700 million monthly users, active users, or something like that, then you need to request a new license from Meta. And Meta could basically decide if they are going to grant that license or not. So there are differences, like minor differences, but important differences.
And why might a company want to consider using an open LLM? What are the
Yeah.
advantages there?
Yeah, that's the debate, I would say, right now in the community, like in which situations you might benefit from using an OpenLM. I would say that they are customizable and very flexible. So if you have like a very specific use case or task, then you could benefit from adapting an open LLM to your use case, because you are going to be running a much smaller model, maybe a 7B model instead of a huge model like GPT-4. Then if you have proprietary data that you could use to outperform your competitors, maybe you could use that data, prepare that data, fine-tune a model, a small open LLM, and then that model is yours, you own the model, and then your competition don't have access to that model. Instead, if you are using closed source models instead, that means that model is going to be available to everyone. So you are at the same level, basically, in terms of competition. So if you have data, it might make sense to use it, prepare it, and tune an OpenLLM for that case. Latency, for example, and you'll remember this very well when we were building some futures at Fluorite, we needed like very fast outputs from the models, and it's not always possible when you're using closed source models, unless you have maybe a lot of money to invest in a dedicated server by these LLM vendors. So with the smaller models, open models, you could deploy them in your servers, and then like get faster responses as well. And then if you are operating in a particular domain, closed source models might not have that knowledge. So domain adaptation is another use case. So you basically could outperform these general purpose models with a smaller model that is domain specific, basically.
Yeah. When implementing an open LLM, you're somewhat on your own. You don't have all of the support that a closed source model and the company behind it would offer. Do you agree? And are there other disadvantages to using an open LLM?
Yeah, that's true. But I have to say that there are companies like Hugging Face that are supporting a lot with those difficulties. We are going in the direction that basically working with these open LLMs is much easier. But it's true that you need probably like more engineering resources, especially if you need to fine-tune that model. For example, you'll need to prepare the data, you'll need to find the right fine-tuning recipe for that task. I think it needs like a bit more upfront investment in terms of resources compared to just like prompting a closed source model using an API. There is also like another consideration, which is basically guardrails. So all these LLM vendors have invested a lot of money in creating strong and stable guardrails. So to prevent harmful content generation, to prevent biases, maybe some data leakages as well. So it's true that the open source community or companies like Meta, for example, building these open LLMs are kind of working on that as well. But it's very possible that you might need additional URLs if you are using an open LLM, and you need to take that into account as well, because that will require some work from your side. It could be also that it takes a little bit more time usually to get the results that you want from an open LLM. So it requires like a little bit more experimentation, especially in the beginning when you are like starting to use that specific model. That could be as well.
So what about the costs? I think sometimes we assume that running an LLM on your own terms is cheaper than using a closed source one, but that might not always be the case, right?
Yeah, you're correct. So in the short term, I would say it's cheaper to use closed source models actually, because LLM vendors like OpenAI and Anthropic, they have been basically leveraging economies of scale. Obviously, they have many clients, and they are basically cutting down the costs per token. But in the long run, I think it could be cheaper because you'll probably be using a much smaller model if you have very specific use cases, and then you could run them in your servers. And I think it could obviously pay off in the medium term, long term. Also, if we forget about the cost, like price per token, basically, and we think more like from the business perspective, if creating your own model, owning that model means that you're going to create IP, obviously that's super valuable for your business as well. So we cannot forget about that and just think about the price per token, right? It could mean that having your own model, that model not being accessible by your competitors is actually what your business strategy is based on, right? So that's invaluable, I would say.
Yeah. And when it comes to making the most out of your open LLM, a tactic that you might employ, although very expensive and time consuming, would be fine tuning, but that might not always be required, right?
Yeah, normally if you have data available, like for a very specific task, you could use it. There are fine tuning methods that are not that expensive in terms of computation, like parameter efficient fine tuning methods like LoRa, for example. It's true that a full fine tuning, especially if the size of the model is significant, could cost some money and it's not as straightforward as one might think. If the task is a little bit complicated or if the data is a bit messy. But yeah, you don't really need to fine tune an OpenLLM to use it. You could use it off the shelf, and there are really good models that have already been fine tuned by the community. And if you have a very similar task and you are operating in a very similar domain, then you could just take that model, deploy it, and use it. And perhaps over time, if you are collecting more data, you could basically adapt it. So you could start with that base model, and then as you collect data and prepare it, you could even making it even better. So it's not always necessary. In the same way that you could use a closed source model, and some LLM vendors give you the option to fine tune that closed source model, although that the difference is that that fine tuned closed source model is gonna stay behind the API, so you are not gonna own it at all. Yeah, in the same way, you could either use the OpenLLM if it's good enough or tune it to your specific use cases or tasks.
There's also model merging as a new technique. And we'll be talking about that in the next episode.
Exactly. So model merging, just like a bit of a preview, basically means merging different models into a single one, retaining their capabilities in that single model. And we'll discuss more about that in the next episode. I think it's a really promising approach that doesn't require many computational resources.
Sounds good. Thanks a lot for this discussion, and see you in the next one, Bernardo.
Thank you, Aro. See you soon.